Section 3.4 talks about derivatives as rates of change. So let S of t be a function giving the position. So it tells you where an object or a particle is at any given time t. Its velocity is given by taking simply a derivative. Speed is the absolute value, and I'll tell you the difference between those. Velocity, if the velocity is positive, that means you're moving forward, right? Or if you're tossing something, it's going up. If the velocity is negative, that means you're moving backwards in reverse. You are moving left, or the object that you threw up is coming down. When you put an absolute value on it, it wouldn't matter. You're just figuring out how fast is it moving. Kind of like if you drive it in your car forward, then the velocity will be positive. If you stop and go in reverse, then the velocity will be negative. But the odometer on the car will always read positive, whether you're moving forward or backward, because that's an absolute value. So it's simply take the absolute value of velocity, and that's speed. Acceleration would be the change of rate of velocity, which would be a second derivative of the original position function. And acceleration is a bit tricky, and we'll talk about that when I start going into the examples really quick, because acceleration and velocity give you a lot of information, but they're not really working the same way. And I'll tell you what that means. Once we get to an example, I'll explain that, and we're getting there soon. So for the following exercises, the given function represents the position. So this S is the position of a particle moving along a horizontal line. Okay, and it's moving in this path. Find the velocity and acceleration. Well, velocity is simply the first derivative. Bring the power down, subtract 1 from the power. Bring the power down, subtract 1 from the power. There it is. Done with velocity. Acceleration is the derivative of velocity, or the second derivative of the original function. Okay. And that turns out to be, oops, there should be a 2 there, right? Bring the power down, subtract 1 from the, yeah. So if you take derivative of this, bring the power down, that's 12t, and that's a -6, and of course that's a 0. There's your acceleration. It says, determine the time interval when the object is slowing down or speeding up. That's a bit tricky, and let me show you how that works. That has to do a combination of velocity and acceleration. Here's the catch. If I'm driving on the freeway, so if I get on the freeway and I start at 0 at the entrance of this freeway and I start speeding up, right? I'm moving forward. I'll get to a speed limit of, let's say, 65. I'm still moving forward. But to get from 0 to 65, the acceleration is positive because I'm increasing the change of rate of velocity. Even though I'm moving forward, right, at a certain velocity, I'm adding to it. Every time I'm adding to it, acceleration is positive. Now, when I get to 65 and I notice my exit is right there, I let go of the pedal, the gas pedal. What happens? Now the car is slowing down, but I'm still moving forward. The velocity is still positive, but the acceleration now is negative because I'm slowing down. And I'll keep on slowing down all the way until I get to a complete stop. So it's very important to figure out where the derivative is positive, acceleration is positive. If the derivative and the acceleration match in direction, that means you're speeding up. If they're in opposite direction, that means you're slowing down. So I need to figure out where's the velocity positive. This is something we're going to do all throughout the course. We're going to take a velocity and figure out where does the velocity positive or negative. To do that, we need to figure out, and remember it's this equation, we need to figure out where is it 0. 0 means you stopped. If the velocity is 0, that means you are at a stop. You're not moving. Well, this is when 12t minus 6, oops, that's when, yeah, you would need to factor. So this happens at t equal 2 and t equal -1. Well, -1 we ignore. We say time cannot be negative. So as far as the velocity is concerned, at 2 we stopped. Before 2, if I pick a point to the left of 2, say 1, if I put 1 right there, or right there, or right there, what do I get? 6 minus 6 minus 12, that's negative. If I put 3, now it's easier to test here, because if you put 3 there, that's positive. 3 there, that's positive. Positive times a positive is, of course, you can put 3 there. But you just want to know if it's positive or negative. So what this means, between 0 and 2, velocity was negative. You were going in reverse, right? Or to the left. In this case, what did they say? They said horizontal, yes. You were going in reverse. And from 2 seconds and on, you are moving forward, which means you must stop to go from reverse to forward. Now let's talk about acceleration. If I take acceleration and I do the same thing, acceleration is 12t minus 6. Where does that equal 0? When t equals 6 over 12, or 1/2. Is that true? Yeah, 1/2. So if I go ahead and match it, there's acceleration. I do the same. If I pick a point to the left, any point to the left, say 0, that's negative. If I pick a point to the right, say 1, if you put 1 there, 12 minus 6 is positive. So whenever they match, again, make sure the intervals are lined up. Whenever they match, you are speeding up. So whenever they match, you're speeding up. So we are speeding up from where? From 0 all the way to 1/2. What happens from 1/2 and on? From 1/2 and on, I'm sorry, from 1/2 to 2, isn't this positive? But this is negative? They have opposite signs. That means you're slowing down. And to the right of 2, aren't they both positive? So what happens here? Whenever the signs are opposite, you're slowing down. Whenever the signs match, you're speeding up. Whether you're going in reverse, so in reverse, I'm going backwards, but I'm increasing. I'm hitting the gas pedal. Even though I'm going back, the acceleration is increasing in negative sense. Here, it's becoming positive, but you're still moving up. Kind of like going in reverse from 0 to 30 and let go of the gas pedal. What happened? You're still moving backwards, but now the acceleration is, you're slowing down. Here, they both have the same sign. That means you are speeding up. And it's as simple as that. So make sure you separate between the two. I know it's a bit confusing. It's negative there and it's positive there. Versus the bottom, it's negative here and it's positive here. So wherever the colors match, that's speeding up. Wherever the colors don't match, that's the only time you're speeding up. You're slowing down. Vice versa works as well. Here's another problem. A ball is thrown downwards with a speed of 8 feet per second from the top of a 64 tall building. That's where the 64 is in. T is seconds. So S is height in feet and T is time in seconds. All right. They tossed the, isn't that an upside down parabola? So if we're saying, except it starts at 64. If we're saying this is T and this is S, that's really how it looks. Determine how long it takes for the ball to hit the ground. Well, if s is the height in feet, for the ball to hit the ground, we want s to be 0, or we want negative 16t squared minus 8t plus 64t equals 0. Factor a negative 8 out, that's 2t squared plus t minus 8, if I'm not mistaken. 8 times 8 is 64, that's correct. And we know this doesn't factor, it doesn't factor. So complete the square or quadratic formula, whatever you like. To complete the square, I prefer completing the square. I would make sure that the leading coefficient is a 1, so I divide by that. I'll take t squared plus t over 2, and I'm going to add a number. Take half of the middle number. Half of the middle number is 1. Take half of 1/2, that's 1/4, and square it. That becomes a perfect square. T plus the number before I squared it. And this is 64 plus 165 over 16. You could use, I should have started this on the left. That is coming. Here we go. Give myself more space. And that would mean I'm looking for t plus 1/4 equal plus or minus square root of 65 over 4. And t would equal negative 1/4 plus or minus square root of 64 over 4. Time can be negative, so we're going to say t equals roughly negative 1/4 plus square root of 65, not 64. I messed up. Square root of 65 divided by 4. 1.8. Roughly in 1.8 seconds, it's going to hit the ground. Determine the velocity of the ball when it hits the ground. What's the velocity of this? V equal negative 32t minus 8. What is that evaluated? Now, since they're asking about this, I want to take a bit more decimals. 1.766. So if I'm only reporting, you could use one decimal. If I'm using that for something else, I should take a bit more accurate points. And what would that be? If I substitute 1.766, it would hit the ground with the velocity of negative 32 times 1.76. By the way, if I put answer, I'll get the exact value, right? If I delete those and use answer instead, because the answer has all of this 1.7555, I'll show you the difference. I'll get 64.5, negative 64.5 feet per second. And if I was to use the other value, just to show you really quick, if I was to use, it's going to be very close, 1.766. I'll be off by a slight number. Negative 64.51. Well, you know, to one decimal, it's all good. And that's how you do those. That's how I figure out all of this. Now they're going to ask something else. Here's another one. The position of a hummingbird flying along a straight line in t seconds. So t is in seconds, and s is in meters in this case. Determine the velocity of the bird at t equal 1 second. Well, the velocity is simply the derivative. Bring the power down, 9t squared minus 7. If I evaluate that at t equal 1, I'll get the velocity to be 9 minus 7. The velocity will be 2, and the units will be meters per second. That's how fast it's moving after a second. How about the acceleration? A would be the derivative of that. That would be 18t evaluated at t equal 1. That's 18 meters per second squared. Those are the units for acceleration. And it says, determine the acceleration of the bird when the velocity is 0. Well, let's see. The velocity is given to be 9t squared minus 7. Where does that equal 0? That's when 9t squared equals 7, or t squared equals 7 over 9, t equal plus or minus radical 7 over 3. Time can be negative. So determine the acceleration. Acceleration is 18t evaluated at radical 7 over 3. That would be 18 times radical 7 over 3. So in your answer, you would say acceleration will be 18 radical 7 over 3 meters per second squared. You are welcome to plug, you could leave it like that, or you could just plug it in a calculator and give me what that result is. What is 18 times radical 7 divided by 3? Oh, that's 6 radicals. I didn't even pay that. 3 divides 18 6 times. That's really 6 radical 7, right? Doesn't matter either way, but you should simplify. That's 15.87. 15.87 meters per second squared. So either of those two answers will do. Here's another one. The position s equal t cubed minus 8t gives the position in miles. S is in miles in this case, and t is in hours. All right. The position gives the position function gives the position in miles of a train where east is positive. So if east is positive, people, what do you think negative is? West? So this train runs east and west. You want to know which way is it heading. Determine the direction of the train. Determine the direction of the train is traveling. So determine the direction in which the train is traveling when s of t equals 0 initially. Well, okay, s of t is right there. That means 0 equal t cubed minus 8t equals 0. Factor a t out. That's when t squared minus 8 equals 0. So that is when t equals 0. T equal plus or minus radical 8. T time can be negative. We have t equals 0 and radical 8 hours. Now what do we need? Determine the direction of the train. We take the velocity. If the velocity is positive, it's moving east. If the velocity is negative, it's moving west. So what's the velocity of this train? V is 3t squared minus 8. If I take this and I evaluate this at t equals 0, v equal negative 8. What? Miles per hour. This is west. If I take t equal radical 8, I'll get v to equal, if you square 8, you get 8. 3 times 8 is 24. Minus 8 is 16 miles per hour. And since it's positive, it's moving east. So the velocity tells you whether you're going up or down, moving right or left, or forward or backwards. Determine the direction the train is traveling when the acceleration is 0. We're still going to use velocity. Acceleration, what's acceleration? This the second derivative. This is the first derivative. So if I take the second derivative, that is 6t. And where that equals 0, when t equals 0. Well, at 0, didn't we agree that the train was already traveling west? So velocity tells me whether the train moving east or west. The acceleration only will tell me whether you're speeding up or not, right? So determine the direction the train is traveling when t equals 0. At t equals 0, the train is traveling at a velocity of 8 miles per hour west, because that's negative. Determine the time interval when the train is slowing down or speeding up. Okay, very good. Here we're going to practice that again. We're going to go on a number line, and we're going to take the velocity, and we're going to match it with the acceleration. Whenever they match, we're in good shape. Let's see. So this is velocity, this is A. If I look at the velocity, we have 0 and radical 8. Radical 8 is a number between 2 and 3, right? It's like 2.8, 2.9. You could figure that out. It's no big secret. What's the square root of 8? 2.8. So we could say velocity between 0 and radical 8, or 2.8, like we said. To the left of 0, there's nothing, of course. We match 0 here, and we'll match the rest. Let's see. Now, we know that if I pick a point in there, say 1, if I put 1 in the velocity, there's the velocity, I'll get 3 minus 8, which is negative. And if I put a point to the right of 2.8, say 3 as a test point, 3. If I put 3 right there, 3 squared is 9 times 3, 27 minus 8 is positive. Now, if I look at the acceleration, acceleration equals 0 at 0, nothing to the left, and no matter what I pick to the right of 0, that's going to be positive. So let's match these colors again. This is negative, this is positive, right? This is positive all the time. So wherever they're different, we're slowing down. We're slowing down from 0 to 2.8 hours. Hours or seconds? I forgot. I forget quickly. Hours. Between 0 and 2.8 hours, we're slowing down. And we are speeding up wherever they match, from radical 8 or 2.8, whatever you like, all the way to infinity. And that pretty much takes care of the section. That's all there is. There are applications on population and some economics. I just want to focus on the parts that's going to come up the most for us. Population will come back again. We'll touch on that a bit, but acceleration and velocity are going to be all over the course, so I want to really focus on that. And that's pretty much it for this section.